Welcome to our channel where we explore the fascinating world of STEM. Discover remarkable scientific discoveries and innovations that shaped our world and explore the stories of brilliant minds who made them possible. Our goal is to inspire a love of learning and passion for STEM while broadening your horizons and deepening your understanding of the world. Come with us and explore the wonders of science, technology, engineering, and mathematics. Fuel cells are devices that convert the chemical energy of a fuel, typically hydrogen, into electricity through a chemical reaction with oxygen. This technology has the potential to provide clean and efficient energy for a variety of applications, including transportation, stationary power generation, and portable devices. In this thesis, we explore the history, working principle, types, and applications of fuel cells, as well as their advantages and challenges compared to traditional energy sources. We also discuss current research and development efforts aimed at improving the efficiency, durability, and affordability of fuel cells, and their potential to play a key role in the transition to a sustainable energy future. Importance: energy is a vital resource that drives modern society and enables economic development, social progress, and technological innovation. From powering homes, businesses, and industries to facilitating transportation, communication, and healthcare, energy underpins almost every aspect of modern life. However, the current energy system is heavily reliant on traditional sources of energy, such as fossil fuels, coal, oil, and natural gas, and nuclear power, which have significant limitations and drawbacks. Firstly, traditional energy sources are finite and non-renewable, meaning that they will eventually run out, and their extraction and use have significant environmental and health impacts, such as air pollution, water contamination, and greenhouse gas emissions. These impacts contribute to climate change, which poses a significant threat to global security, stability, and prosperity. Secondly, traditional energy sources are subject to price volatility and geopolitical risks, which can lead to energy insecurity, market distortions, and conflicts. Finally, traditional energy sources are often centralized, requiring large and complex infrastructure to generate, transport, and distribute energy, which can be vulnerable to disruptions and failures. To address these challenges, there is an urgent need to shift towards clean and sustainable alternatives that can provide reliable, affordable, and low-carbon energy. This transition requires the development and deployment of innovative technologies that can harness renewable energy sources, such as solar, wind, hydro, and geothermal, and convert them into electricity and other forms of energy. Fuel cells are one such technology that holds great promise for the future of energy. Fuel cells are electrochemical devices that convert the chemical energy of a fuel, usually hydrogen, and an oxidant, usually oxygen, directly into electricity, without combustion or emissions. They are highly efficient, with conversion efficiencies of up to 60%, compared to 30 to 40% for traditional power plants. They are also modular, scalable, and flexible, making them suitable for a wide range of applications, from small portable devices to large stationary power plants. Furthermore, fuel cells produce only water and heat as byproducts, making them a clean and sustainable alternative to traditional energy sources. History and background of fuel cells. Fuel cells have a long and fascinating history that dates back to the early 19th century. In 1839, Sir William Grove, a British lawyer and scientist, discovered the principle of the fuel cell while experimenting with electrolysis. He observed that by reversing the process of electrolysis, it was possible to generate electricity from hydrogen and oxygen. He called his device the gas voltaic battery, and demonstrated its operation by powering a small electric motor. Over the next century, several researchers and inventors worked on improving the design and efficiency of fuel cells. One of the most notable was Francis Thomas Bacon, a British engineer who developed the first practical fuel cell in the 1930s. His fuel cell used a potassium hydroxide electrolyte and a nickel anode and cathode, and it was capable of producing up to 5 kilowatts of electricity. In the 1950s and 1960s, fuel cells gained popularity as a potential power source for spacecraft and other applications that required a reliable and lightweight source of electricity. The U.S. space program, in particular, invested heavily in fuel cell technology, and in 1965, the Gemini V spacecraft became the first vehicle to use fuel cells for power. Since then, fuel cell technology has continued to evolve and improve, with significant advances in materials science, engineering, and manufacturing. Today, fuel cells are being used in a wide range of applications, including transportation, stationary power generation, and portable electronics. The basic principle of fuel cell operation is based on the electrochemical reaction between hydrogen and oxygen. A typical fuel cell consists of an anode, a cathode, and an electrolyte. The anode is typically made of a porous material such as carbon paper or graphite, coated with a catalyst such as platinum. The cathode is also porous and coated with a catalyst. The electrolyte is a proton-conducting membrane that separates the anode and cathode. When hydrogen is fed into the anode and oxygen into the cathode, the hydrogen atoms are split into protons and electrons. The protons migrate through the electrolyte to the cathode, while the electrons travel through an external circuit to the cathode, creating an electrical current. At the cathode, the protons and electrons combine with oxygen to produce water and heat. Types of fuel cells. There are several types of fuel cells, each with its unique characteristics and applications. The most common types of fuel cells include proton exchange membrane (PEM) fuel cells, solid oxide fuel cells (SOFCs), direct methanol fuel cells (DMFCs), and alkaline fuel cells (AFCs). In this section, we will describe each type of fuel cell and its advantages and limitations. In addition to these types, there are also phosphoric acid fuel cells (PAFCs), molten carbonate fuel cells (MCFCs), and others, each with their unique advantages and limitations. Fuel cell components and materials. A fuel cell consists of several components, each of which plays a critical role in its operation. The main components of a fuel cell include the electrodes, catalysts, electrolytes, and supporting structures. Designing and manufacturing fuel cell components can be challenging, particularly because of the harsh operating conditions and the need for high durability and performance. For example, the electrodes and catalysts must withstand high temperatures and resist corrosion, while the electrolyte must maintain high ionic conductivity over a wide range of temperatures and humidities. Additionally, the cost of materials, particularly catalysts such as platinum, can be a significant barrier to commercialization. To address these challenges, researchers are exploring alternative materials for electrodes, catalysts, and electrolytes, such as non-precious metals, metal oxides, and polymers. They are also developing novel manufacturing techniques, such as 3D printing and roll-to-roll processing, to improve the scalability and cost-effectiveness of fuel cell production. Applications of fuel cells. Fuel cells are electrochemical devices that convert the chemical energy of a fuel directly into electrical energy, without combustion or mechanical parts. This technology has been developed for several decades, and it has potential applications in various fields, including transportation, stationary power generation, and portable devices. Transportation. One of the most promising applications of fuel cells is transportation, especially for vehicles. Fuel cell vehicles, FCVs, are electric vehicles that use hydrogen as a fuel to generate electricity through the electrochemical reaction between hydrogen and oxygen. FCVs have several advantages over traditional internal combustion engine (ICE) vehicles, including higher energy efficiency, lower emissions, and quiet operation. However, FCVs also face several challenges, such as high costs, limited fueling infrastructure, and safety concerns. Currently, FCVs are still in the early stage of commercialization, and their market adoption is limited to a few regions, such as California, Japan, and Europe. The cost of fuel cell systems and hydrogen production, storage, and transportation infrastructure are still high, and the lack of a robust and widespread refueling network is a significant barrier to widespread adoption. Stationary power generation. Fuel cells can also be used for stationary power generation, providing electricity for residential, commercial, and industrial applications. Stationary fuel cell systems can be combined with other renewable energy sources, such as solar and wind, to provide reliable and efficient power. Stationary fuel cells have several advantages over traditional fossil fuel-based power systems, including higher energy efficiency, lower emissions, and reduced noise pollution. However, their high upfront costs, limited durability, and dependence on hydrogen or other fuels are significant challenges that need to be addressed. Currently, the stationary fuel cell market is still in its early stage, and its adoption is limited to niche applications, such as data centers, hospitals, and military bases. However, with the increasing demand for cleaner and more reliable power, the stationary fuel cell market has significant growth potential, especially in regions with high electricity prices or unreliable grid infrastructure. Portable devices. Fuel cells can also be used for portable devices, such as laptops and mobile phones, providing longer battery life and faster charging. Portable fuel cells use small amounts of hydrogen or other fuels, and they can generate electricity through the same electrochemical process as stationary or transportation fuel cells. Portable fuel cells have several advantages over traditional batteries, including higher energy density, faster charging, and longer lifespan. However, their high costs, limited availability, and safety concerns are significant challenges that need to be addressed. Currently, portable fuel cells are still in the research and development stage, and their market adoption is limited to a few niche applications, such as military and aerospace. However, with the increasing demand for longer battery life and faster charging, the portable fuel cell market has significant growth potential, especially in high-end consumer electronics and remote or off-grid applications. Advantages and challenges of fuel cells. Fuel cells offer several advantages over traditional energy sources, including: despite these advantages, fuel cells face several challenges that limit their widespread adoption. To address these challenges, researchers are exploring several avenues of research, including future directions and research opportunities. The field of fuel cells is ripe with opportunities for future research and development, with the potential to revolutionize the way we produce and consume energy. Some of the key directions and opportunities for research in this field include: all-in-all fuel cells have the potential to revolutionize the way we produce and consume energy, offering a clean, efficient, and sustainable alternative to traditional energy sources. However, their widespread adoption is still limited by factors such as cost, durability, and scalability, as well as the need for supportive policy and market incentives. Despite these challenges, the research and development efforts in the field of fuel cells continue to make significant progress. The development of new materials, manufacturing processes, and system designs is continuously improving the performance and durability of fuel cells, while also reducing their cost. Moreover, the integration of fuel cells with renewable energy sources such as solar and wind is expanding their potential applications and improving their sustainability. Future research and development efforts in the field of fuel cells should continue to focus on addressing the existing challenges, such as developing better catalysts, improving the durability of the electrodes and electrolytes, and increasing the scalability of production processes. Furthermore, research should also explore new applications and markets, such as aviation and marine transportation, and investigate the potential of hybrid systems that combine fuel cells with renewable energy sources. Finally, policymakers and market actors should provide the necessary policy and market incentives to promote the uptake of fuel cells. This could include measures such as carbon pricing, renewable energy targets, and supportive regulations and standards. So there it is, fuel cells represent a promising technology with the potential to transform the energy landscape in a sustainable and efficient way. With continued research and development efforts and supportive policy and market incentives, fuel cells can become a mainstream energy source and play a key role in the transition to a sustainable energy future. Thank you for joining us on this journey of discovery and exploration. We hope you've enjoyed learning about the wonders of science and the incredible breakthroughs that are shaping our world. From uncovering the mysteries of the universe to tackling some of the most pressing challenges facing humanity, science truly has the power to transform our lives and our world. We invite you to continue exploring the amazing world of science, and to join us in our mission to promote scientific understanding and knowledge. Stay curious, keep learning, and always keep asking questions. Who knows what incredible discoveries lie ahead? Thank you for being a part of our community, and we look forward to continuing this journey together.